In problem 60, we want to find a polynomial f of x with real coefficients having the given degree and zeros. So we know that the degree is 3, which means that there have to be 3 factors. So I have f of x equals 1, 2, 3 factors. The first 0 is negative 3. So I have x minus a negative 3, which makes x plus 3. The next 0 is a complex 0. So that's going to be x minus, and then in parentheses inside here, 3 minus 2i. So they only gave us 2 zeros, but the degree is 3. We're missing 1. But whenever you have a complex 0, like we have here, then we always have its complex conjugate as a 0 as well. So my last 0 is x minus 3 plus 2i. And that's my final answer. I think in the solution, because it says with real coefficients, they're going to FOIL it out. So you can FOIL it out. Let's go ahead and do that. So we have x plus 3. I'm going to always multiply the ones with the complex zeros together first, because things are going to cancel out. It's going to be a lot nicer. So I have x times x gives me x squared. Then I have x times the minus 3 plus 2i. So that's going to give me a minus x times 3 plus 2i. Then we have our x times a minus 3 minus 2i. So that's x, 3 minus 2i. Oops. And then finally, we have the opposite of 3 minus 2i times the opposite of 3 plus 2i. So that's going to make a plus. The two negatives multiplied together makes a plus. And we have 3 minus 2i times 3 plus 2i. And we close the parentheses on that. Okay, so let's bring down the x plus 3. The x squared comes down. I distribute my minus x, and I get minus 3x minus 2xi. You can change the order in that. It's not really important. And then I'm going to distribute my next minus x, and I get a minus 3x and a plus 2xi. And then finally I multiply my two complex numbers together, and because they're conjugates of each other, we know that the middle terms are going to cancel out. So 3 times 3 is 9, and negative 2i times plus 2i gives a negative 4i squared. Okay, let me shift this up a little. Oh, that didn't work. There we go. Okay, so let's see, we bring down the x plus 3, and we have a minus 2xi and a plus 2xi. Those cancel each other out. And I dropped the square on here, didn't I? So there's that square. All right, so x squared, negative 3x makes a negative 6x. And then we have a plus 9. And minus 4i squared makes a plus 4. So then we have x plus 3 times x squared minus 6x plus 13. We're not done yet, but we're close. So then next, I need to distribute the x to every term. It's not really FOIL, but it's the same basic concept. And then we'll distribute the 3 to every term. And then we'll combine like terms, and then we'll be done. So we have x times x squared gives me x to the third. X times a minus 6 gives me minus 6x squared. X times plus 13 gives me plus 13x. And one trick to at least get your like terms to line up is that next I'm going to go plus 3 times x squared and line up those like terms. So that way they're automatically grouped together. Saves you a second in the end, so it's nice. Plus 3 times a minus 6x gives me a minus 18x, and 3 times 13 is 39. And finally we get x cubed minus 3x squared minus 5x and a plus 39. And so that's my final answer with real coefficients for f of x. Now let's take a look at 61. Let me grab that real quick. Okay. And we have a polynomial with degree 4 and zeros 1, -1, and 4 minus 2i. So the same basic concept of what we did before. Oops. Okay, here we go. So we have f of x equals x minus 1 from the plus 1, x plus 1 from the minus 1, because remember we're always subtracting the 0, so it's always going to be opposite in sign. And then we have x minus 4 minus 2i. And since this was a complex 0, our fourth 0, and we knew we had to have 4, so our last 0 is x minus 4 plus 2i. Okay. So f of x is going to equal, I'm going to go ahead and multiply this x minus 1 times x plus 1 because it multiplies so nicely and we get x squared minus 1. So that's nice. And then we multiply our complex zeros together, or the factors with the complex zeros, and I get x squared, x times a negative 4 plus 2i. And you can skip steps here a little bit if you're comfortable with that. So it just depends on how comfortable you are with distributing right away. So that's up to you. Minus x times 4 minus 2i. And, oops. Okay. And then we have negative 4 minus 2i times negative 4 plus 2i. So that's going to give me a plus 4 minus 2i, 4 plus 2i, and that's all in there. All right. Oop, I ran out of room. Okay. So we have x squared minus 1 times x squared, distribute my x, distribute the next x, and we realize immediately that these two terms are canceling out. And now I'm going to multiply the 4 minus 2i times 4 plus 2i, and I get 16 minus 4i squared. So we have x squared minus 1 times x squared minus 4x and a minus 4x gives me minus 8x. Let's see. Then we have a plus 16. and the minus 4i squared gives me a plus 4. So this is x squared minus 1 times x squared minus 8x plus 20. And then this is going to be, oops, I don't need a parenthesis anymore, x to the 4 minus 8x cubed plus 20x squared minus x squared plus 8x minus 20. And so when we combine like terms, let's see if I can squeeze it in here. We're going to get x to the 4th. We have minus 8x cubed plus 20x squared minus x squared gives me a plus 19x squared plus 8x minus 20. So I had to squish it in there, but we've got our final answer here with all real coefficients. And that's how you would do those two problems.